So, good evening, everyone. Welcome to the week one of the live interactive session of Neural Science for Engineers. The course is being taught by Professor Vikas V from Nimans, Bangalore, and I am the PMRF teaching assistant Vikas Pandey from IIT Jodhpur. So, before starting, since this is the first class, I would like to know the background of you all. And I will, am I audible? Sorry, you can unmute and speak up. Anyone?
Yes, sir, you are audible, sir.
Yeah. So before starting the course, I would like to know the background of the audience so that it will be easy for me to understand. So let's start from you, Valli. Niranjana. Okay. Yeah. Can you give your background, what you are doing or what you have done? What is your professional background?
Sure, sir. Hello,
Yeah.
everyone. I am Niranjana. I am a second year biomedical engineering student from Rajalakshmi Engineering College in Chennai. So,
Mhm.
yeah, so one of my regions of interest is in neural science and using AI and ML in various biomedical applications. So, I thought this might be a good opportunity for me to get to know the basics. So, that's why I enrolled for this course.
Sure. So next, I think Paritosh Tomar. Are, are you there?
Yes, sir. Yeah,
You
good
can
evening,
introduce
everyone.
yourself.
Yeah,
Yeah.
good evening, everyone. I am Paritosh. I am a third year BTech student at NIT Calicut. I am doing my bachelor's in material science and engineering. So, as Niranjana also mentioned, that this field of neuroscience is very fascinating. So, me coming from a different background, I wanted to know about a lot, a lot about this field. And way before enrolling into this course, I watched like several lectures, not as a course specifically, but uh, just as a like lectures from YouTube of Dr. Vikasvi and Dr. Hardik as well. So yeah,
Yeah.
thank you.
Oh, great. So next, I think we can ask, yeah, Nikita S. Raj.
Hello, everybody. This is Nikita here. So, I'm doing my CSC BE in RV College of Engineering, Bangalore. So, I just like the course. I have like a keen interest in neurology, so I wanted to take this course.
Great. And next, I think Saji, you are left.
Uh, Good evening, sir. This is Saji. I'm working as a scientist in DRDO, mainly working in artificial intelligence side. So I took this course to understand how our brain works and can we imitate some quality of that one through our codes. So last 20 years I'm working in this as a DRDO scientist at Visakhapatnam.
Yeah,
Thank you.
great. So in fact, I will also be learning a lot from you. So, let me introduce myself. Uh, I am Vikas Pandey. I am a PhD scholar in space science and technology at IIT Jodhpur. Uh, as far as my academic background is concerned, I have done an BTech in Electronics and Communication Engineering, MTech in VLSI, that is also part of Electronics and Communication, and I have worked as a robotics trainer, online faculty, and R&D engineer. For more details, you can visit my portfolio page. The schedule for this class will mostly remain the same, that is Tuesday, 6 p.m. to 8 p.m. And the Meet link that you have joined, that will also remain same throughout this semester. And all the classes will be recorded and put on the YouTube channel until unless there is some recording glitch. Mostly all these are recorded, as well as in the course you will see at the last there will be a section called live interactive sessions. There from there you can access this all the slides that we will use in the class. So anything till here, like any questions or anything you would all like to have, or any questions you have faced during this during the class, because I will not be taking the class as such. I'll be like this will more be more like a tutorial. Like we will be solving some problems that are related to the things taught in the class. Okay, and I will not be directly discussing the assignment problems since they are due. They are not like they are still due. So before starting the questions, any question related to anything that you want clarification from the week one, you can ask. Anyone?
Any study materials are available, like videos or some animations
Uh,
or something like that. It is useful for
uh,
brain
yeah,
function.
actually, I think this is quite a unique course and like a very less amount of material is available in like specifically neuroscience for engineers. Okay, so if I get something, I will certainly share in the class. Okay, yes. So I think we can move forward. Any other questions?
Yes, sir. Yes, sir. I would like
Yeah,
to ask a few questions. So, what
yeah.
was the error checking mechanism sir was talking out throughout the lectures?
Error checking mechanism is like the feedback. You must be aware of feedback system that if you have a system that is done in neural networks also. If you have something like say you are putting an input X and you are getting. So since I am from an electronics background, I would like to explain it in the terms of like what I know better. Okay. So you can say that this is a system, like this is a any machine or any system through which a signal is input and we are expecting a signal Y. Okay. But we are not getting the signal Y. We are getting something as Y1. Okay. So this difference between Y and Y1, Y minus Y1. Okay. This will be feedback like inserted through the feedback system in mostly negative feedback systems, which will go and change the input. Like it will manipulate the input a bit so that we are getting closer to the output Y. Okay, and this will continuously run till we get this Y minus Y1 equals to 0. Okay, are you getting the idea
Yes, sir.
what it is? So it
Yes,
is
sir.
error checking, we can say as negative feedback kind of thing. This as the course progresses, I think it will be much clearer. Yeah, any other questions?
So, moreover, when we were talking about the inside charge of the cell to be negative
Mhm,
and the outside to be positive, we were mentioning that there is a free flow channel for potassium, which
mhm.
is like simply moving the inside potassium to the outside, and that's why the
Outside.
negative charge is coming in to the inside. Why are we not
Yeah,
having free flow channel for sodium?
it is like you must have seen that when sir was discussing that there are some gates like there are selective gates, you can see the channel that allows the free flow movement. Okay, like between two axons. No, okay, this is quite selective towards you can say chemically also, since you are from material science, right? Paritos, you are from material science, right?
Yes, sir.
Yeah, so you must be aware that the same material will respond. uh, First thing is that I'll not be able to check the messages during the class since I am on the video call. Okay, so you can unmute and speak up whenever needed. Okay, so the thing is that since it is you can say that the same chemical or the same material. Suppose we have a material which is such that it has more. You can say it is more chemically selective towards some specific ions. Okay, that those ions will bond on that specific material easily compared to other ions because there is an if it is suppose that it is adsorption adsorption is happening, so some potential, some energy is required for that specific adsorption to happen. In this case, the flow, the flow uh, that gate will allow the flow of that specific ion only because it is selective towards that ion. So if we study the chemical properties of it, it will become even more clearer. Yes, I think someone asked a question. Yeah, Aditya Bhalla. First, you can introduce yourself and then you can ask your question, please. Hello, Aditya Bhalla, are you there? Hello. Okay, any other questions?
So one more thing, like
Yes.
now itself, I got this point about the selectivity of the flow of ions through the channel, but when we were talking over there, we were mentioned that we only have free flow channels for potassium. So is it possible to have that for sodium as well?
Yes, there are for all the three, like there are different, but in different scenarios, different kind of gates.
Okay, so in
Like,
that case, when we talk about charge imbalance, so charge imbalance is the thing which is causing things to be alive, right? And but
yeah,
imbalance itself means it's unstable. So how is it like life
in
itself is unstable?
if there
I
is no
didn't get
flow,
the point.
yeah,
Yeah.
the thing is that uh, if you know about potential, right? Voltage, gradient, or potential, you can say. Are you aware of it?
Yes, sir. Yes, sir.
So, to put it very simple in layman's term, let's say that our in our brain, the signals travel from one place to another. Okay. And for anything to go from one place to another place, what should be there to move?
Medium.
For something to move, first medium is there, fine. Then the second thing is a medium that allows that movement, first thing,
Yes.
right? Second is there should be a gradient. If
Mm.
you keep a ball on a flat surface where there is no gradient, like there is no slope, nothing at all, what will happen? It will remain there, right? So
Right.
no movement will occur. Whereas if you are putting something on a sloped surface and a ball on the sloped surface, there will be movement. So in case of life also, for this signals to travel, there is a gradient. So you and if there is equality, like all the places in our axons and neurons are at the same position, then what will happen? There will be no transfer of signal. That is the issue that not issue. That is the way it happens because if there is no difference, then there will be no gradient, and if no gradient, there will be no flow of charge.
Mm.
Fine.
Got it, sir. Yeah. Thank
Yeah.
you.
Okay. Any other questions? Okay. So let's start with our first questions. First question, that is, what is the resting membrane potential of a neuron? Is it plus 30 millivolt, 0 volt, 0 millivolt, or minus 70 or minus 30? Any answers?
minus
Minus
70
70.
millivolt.
Minus
Minus
7.
70. Okay. Any other answers? Yes. Parithos, will it be 0?
No, sir. It will be minus 70.
Minus 70. So if it is 0, what will happen? There will be no flow. Th- that is that actually answers your question that if we have uh, 0 potential, there will be no flow. Okay, no flow of signals or signal or information or messages, whatever you say, or ions. Okay, whereas since you have a potential, there is a difference. That is why there is a flow of signal. The resting is the stable voltage difference across a neuron's membrane. Okay. Okay. And since it is minus 70, that means there is more negative charge inside the cell compared to outside the cell. Exactly the thing that you were discussing. Fine. Any doubt in this? Okay. So, what initiates the depolarization phase of an action potential? Hello? Yeah, any answers to this?
Sodium channels opening.
Sodium channel.
Sodium channel opening. So, this initiates the depolarization phase of an action potential. Okay. So, when voltage gated sodium channel opens, it allows the sodium ions to flow into the cell. So, sodium ions are Na plus or minus?
Plus.
Na plus. Na
Plus.
plus.
Plus. And inside, like, I'm not very good in drawing, so I'm just making a cell like this. Okay. It does not look like neuron, but still, let's assume it is. Okay. So we have some negative potential inside. When the positive will go inside, what will happen?
It will neutralize.
It will neutral. It will decrease the potential. The potential when the gate was closed, there was a difference between inside and outside, and the difference was minus 70 millivolt. Right now, when this allows the entry, the depolarization occurs. So this sodium channel opens. And why is it being called sodium channel? Because it selectively allows sodium to pass through it. Okay. And this positive ions will enter into the cell, leading to the initiation of an action potential. Like first there was a gradient, and now there will be an action potential. It is more like a current, you can say. In general electrical terms, you can say it will start a current.
So actually my doubt was this thing only.
Okay.
If we can have sodium channels which is decreasing the potential, we can also have potassium channels which is doing the same thing. So why
Yes.
specifically sodium channel is the answer?
Because the gate, this gate, let me put some colors. Yeah. The gate, uh, the gate that is here, that in this case, the gate is specifically sodium, allowing sodium to enter.
So
Like,
does it depend on the size of the ion, or like is it about the electropositivity of the ion? Like what property makes sodium suitable and not potassium?
the, uh, you can say, since we have said that this is a membrane, okay? So you are actually giving the answer in your question itself, okay? It is a membrane and it allows something selectively. So, what can be the reasons that it is allowing selectively? It is a membrane, so the diffusion will occur, right? Something will move from here to there only through the pores, right?
Yes, yes.
Okay.
I think some chemical reaction may happen, and only
Yeah,
sodium can. That is one point.
yeah,
Another thing may
yeah,
be the potassium size and sodium size will be different. Na
different.
plus maybe 11 and K is will be some another
Yes,
size. So that
yeah,
much big size it may not allow to go inside.
yes. So there are both these points. First is if you check its chemical composition also. I am not very well aware about the gates chemical composition. Okay, but they allow selectively, and since it is a membrane structure, so it will allow those ions which are smaller than the uh, size of its hole or the opening, right? But this is also opening and closing. It is not always open. So once it opens, the sodium ions are able to flow inside. Fine. Aditya?
Yes, sir.
Yeah. And I think you are not able to join earlier. So can you introduce yourself? Like, what is your academic background or what is your professional background?
Hi, sir. I am Aditya Vella. I am from BTech grad course, and I'm in my final year of graduation. I'm doing my BTech from NSUT Delhi.
In which branch?
I'm in instrumentation control engineering branch.
Okay, great. Okay. I am asking the background so that from the next time I will also be prepared what kind of things I can use for you people to understand, because knowing your background will help me. Okay. So
Sir, this topic
yeah,
was like covered in our graduation time in class 12 chemistry, so it is very common.
yeah, yeah. Membrane and these things, yeah, mostly people know, right? Membrane, how flow. You must have read about reverse osmosis and osmosis process, right? It is very similar to that. It is oligosaccharide based membrane. Okay. So what initiates the depolarization phase? That is sodium channel opening. Then next question, which ion is responsible for repolarization during an action potential? So this one was depolarization and this one is repolarization during action potential. So is it sodium, potassium, calcium or chloride? Yes, anyone? Hello.
So in that
Potassium.
case, it has.
Potassium, it will
What?
go outside.
Potassium will go outside. So potassium ion should be responsible for repolarization. First sodium was entering and here potassium is responsible for repolarization. Okay. Where cell returns to its resting stage. So resting stage was minus 70 millivolt. Okay. The potential changed. That is, in this case, since it was negative, we will say it increased. Okay. Then it is again reaching the minus 70 millivolt. So what is happening here? First, this was depolarization and this one is repolarization. So here, sodium channels were opening. Sodium was entering in, and this one is achieved by opening sodium channel, allowing, opening of the potassium channel, allowing potassium ion to move out of the cell, restoring the negative charge inside. Okay. Next is the action potential is considered the fundamental method of communication in organism with respiratory system, digestive system, nervous system, or muscular system.
Nervous system.
Nervous system.
Nervous
Since
system.
that is the since that is where communication signal or information flow occurs. Okay. Since this is beginning, we will be going with very simple questions and will not be going very technical at first. Once the course moves forward, we will be going in details. Okay. And action potential, that is, if you say it is very much like the Ohm's law that if there is a gradient, there will be flow. Everyone is aware of Ohm's law. Ohm's law
Yes, sir.
in
Yes, sir. Yes.
Yes.
electrical, right? So this is when we hear the term, when we are hearing it from biology perspective, we think that okay, this might be something different, but this is very much similar to that. And in fact, there are many systems that are designed using the like that has been designed studying from the natural things. Here, the action potential is something like that. There is a gradient, okay, and due to this gradient, this flow, like we have voltage, and then there is a flow of current or signal. A similar mechanism occurs in case of our nervous system. Okay, neurons have axons. If we say this is a neuron, right? So they have axons and dendrites, right? And at the interface of axon and dendrite, they have this gates, specific ion gates that allow the signal to okay? Transmit signal and communicate with each other. So it is the nervous system. I should. What is the role of refractory period in an action potential? Any idea about this? It enhances depolarization, allows immediate resimulation, prevent immediate resimulation, or slows down repolarization.
Prevents
Yes.
immediate restoration.
What prevents immediate resimulation, right? And how it does that? Yes, anyone can answer.
It requires some threshold potential. So because of
Yes,
this, it may not reach the threshold potential and can prevent the re-stimulation.
yes. So it is a brief time followed by an action potential. Okay. So during this time, the neuron is less responsive to the additional stimuli. Any external stimuli is something like again a gradient or potential. Okay. So this prevents the immediate resimulation of neuron, ensuring that proper signal propagation occurs. So this is something like in our computers, if we give multiple commands, so what is the best way that if one command is running, it will ignore other commands for some time till the execution of that thing is done. Okay, a similar process. If is this example clear, or should I go for something else?
So the reason is what? Because the reason is I think that next
Hmm.
stimuli comes, why response
Hmm.
is not coming? Because of it may not reach that threshold level.
Yes. So, like, yes, if you say in terms of, say, gate potential or something, in case of a transistor, that if it might not have reached the threshold level required to switch it on or switch it off, right? Everyone is getting this point?
Yes, sir.
Okay. And if you are not getting, you can easily ask. You can just unmute and speak. Okay. And I think Anu Krishna, yeah, you were also not, you didn't join it first, right? So can you introduce yourself?
Yes, I am Anu Krishna actually from Nimans Institute.
Okay. So you are from the from Nimans itself, right? So you are
Yes, yes.
doing graduation there, or
Yes, yes, I am doing graduation actually
okay,
in clinical neurophysiology.
okay. So uh, I will take help from you because since I am not too much from biological background, so wherever I'm not in the right track, you can just say, okay.
Yes,
I
of
am
course,
more,
sir.
I am more in from circuits and you can say AI, ML, and
I
these
want that
things.
side actually. That's why I'm here.
Yeah.
I want that
So
perspective.
yeah. So let's go further. So this allows, you can say, it allows some relaxation time. so that this signal, this first stimulus is, what I understand is that first stimulus is processed, or first signal is processed. This signal is already inside, so it gives some time so that this processing completes. Then only the next signal will enter, or next stimulus will enter. Okay, so that there is no confusion or no overloading, or two signals are being processed at the same time. So which part of the neuron is responsible for transmitting axon potentials? Dendrite, cell body, axons, or synapse?
Axon.
Axons, right? So it is the, if you see the neuron, like so, no, I think so. This nucleus. So I am not drawing the dendrites and all. I'm just, so if, yeah. So this part, the longer part, sorry, I just got, yeah. The longer part, that is axon, right? And this is responsible for carrying the, for transmitting the axon potentials. Fine. Anything anyone would like to add on this, or any questions?
सर इसका मल्टी नहीं हो सकता लाइक एक्सॉन और साइनैप्स दोनों
Synapse. What is synapse? Is it
सर
part of?
the gap between two neurons like the axon of first and then
Yeah,
dendrites of second.
yeah, of second or axon, like that is the, like you can say that is the gate area. Okay, so
Yes.
it is not transmitting, it is just switching it on and off. This transmission is being switched on and off using the synapse. Okay, but axon is the one that is responsible for communication with other
Okay,
neurons.
sir.
Okay, you can say, certainly that also have a role in it, but we can say that this is primarily, actually, is primary, I can say, primarily responsible for transmitting axon potential. Fine. Okay. What is the significance of the amplitude of an axon potential? It determines the frequency of axon potential, that is, how fast this axon potential will occur. It represents the strength of the stimulus. That means, how much stimulus has been received. Is it small or large? Or it remains constant across different membrane segments? Or it influences the speed of transmission? So what is the significance of amplitude of an axon potential?
It
Yes,
remains constant.
it remains
Yes, sir.
constant.
It remains
Yeah,
constant throughout.
throughout. And why is it so?
Because it is the same action. You have seen that minus 70 millivolt, it will go again to some 30 millivolt and come back to the position. So this
Yes,
is a cycle. This cycle is constant throughout.
throughout. Yeah, it is essential for maintaining the integrity of the signal as it travel across the, along the neurons, right? So it remains constant across different membrane segments. In terms of wave dynamics, axon potentials create oscillations, traveling wave, standing wave, or resonance. Are you aware with these terms? Oscillation, traveling wave, standing wave, resonance. Yes,
Yes, sir. It is a traveling wave.
traveling wave. And how do we know that it is a traveling wave?
it moves from one point to another point, and
Yeah,
amplitude and most probably the frequency also constant for one particular uh, time. So we can call it as
yeah,
traveling. Standing
yeah,
waves will not move, and
yeah,
resonance means two frequencies very close to each other. Amplitude suddenly will increase. That's called
increase.
resonance.
Yeah, resonance. Yeah,
Oscillation
both.
means it is a simple harmonic motion where
Yes.
your
So,
acceleration is maximum.
any other example of traveling wave we see in our daily life?
Sound I think is
Sound.
traveling wave.
Yeah, sound. So, which actually moves the medium, like which makes the uh, which makes the medium move forward, like using compression and decompression. Sound goes like that, right? The medium is not carried, but the wave goes. Like the medium remains there, oscillates, and it transfers this frequency or energy forward. So these are called traveling waves. And action potential generate traveling waves along the cell membrane. Okay, and since it is moving, we can also say that since the wave represent propagation of electrical signal along the axons, it is it is a traveling wave. Fine. Any anything in this? Yes. Anyone would like to have any question? Okay. So let's move forward. What initiates the generation of action potential in response to an external stimulus? Activation of chloride channel, changes in protein conformation, activation of calcium channel, or change in mitochondrial activity.
Changes in protein conformation.
Changes in protein conformation. So this initiates the generation of external action potential in case of external stimuli. Okay. So our changes in conformation, voltage gated ion channels in response to this change is in protein structure allows ion to move across the membrane, generating action potential. So, okay. Yeah. So uh, as as we were discussing earlier also, there are two things. First is structure, okay, and second was is uh, in the structure itself we can say, or we can say chemical, not chemical structure, but we can say it as chemical composition. Okay, these are structure and the chemical composition. These are two things that allows the movement of specific ion through a membrane in case of this ex, uh, action potential. Fine. So this external stimulus, this changes the protein structure. That is the protein structure of the gate, the channel gate. Okay, and this activate it's like it switches it on or off, and thus generating the action potential across this in the neurons. Fine. Yes. Any questions?
Uh, for a small, not doubt actually, it's a small
Yeah.
query.
Yeah.
See, if it is so, so when we give externally with our electricity, this 30 millivolt and or if you provide, then we
Yeah.
can ourselves we can control. We put some chip or something.
Yes. That far I cannot say, but yes, I will say that some techniques where we are measuring, since we are already measuring the action potential and all, certainly if we are giving specific values of these voltages, certainly we can have some changes. We will be able to like though I think that going inside the brain and like connecting to the brain and then giving this this potential itself, that is a bit difficult and risky, but certainly that will simulate the action potential. Yes, Anu Krishnan, yeah, you were trying to say
Can I
something.
add something? Yes, yes.
Yes, yes, sure.
Because there are many electrophysiological tests in which we are actually giving current. They are actually
Okay,
stimulating many nerves and all for the
okay,
same reason.
yeah. So, like,
They are,
is it not harming the patient? Like,
it doesn't harm as such, but still, anyways, there is some changes which will happen. But it
okay,
won't create any big issues. Any side effect as
okay,
such, it won't create. But since it will be little discomfort for the patient always,
yeah, like you
as
are
we are
going
currently giving
inside,
current.
right? Okay,
No, even from I mean from outside also we can stimulate
okay,
because it will
okay,
pass through the skin and also it will.
okay. Like
Even the
using
other thing also we do.
yeah,
Yes, sir.
okay, using RF signals and this you are saying.
Yes, yes. No, not RF signal actually. Like normally we attach the leads and give the current like that.
Okay,
Yes,
I
but
have seen in this neuro
very less millivolt.
stroke
yeah,
patients and all, they put that they cannot move your legs and
yeah. In
hands.
that case, they
And in
yeah
that
they
they will
send
put
signal.
some
Yeah,
electrodes and give some pulses. I don't know how much
Yeah,
it
yeah.
is.
That is kind of one
one.
therapeutical effect of this thing.
Okay,
That we can
Uh,
actually move the muscles and all, so that that movement of the muscle will still maintain the muscle integrity.
great. And yeah, Niranjana, you were trying to say something.
So there is actually an therapeutic equipment that's being used called TENS, that is transcutaneous electrical nerve stimulation. So what they
Okay.
basically do is they just give a voltage and voltage that is given upon the skin. So that
Mm-hmm.
helps in stimulating the nerves. So basically, they're generating an
Okay.
action potential artificially.
Excellent.
Uh, like
Okay.
Sajid sir said, it's being used in stroke patients.
Okay. So certainly, like as we like as we, Sajiji was asking that can we do the reverse of it? Not reverse. Can we do it artificially? So certainly we can do, right? And it is being done, right? So yeah, can we move forward? Hello, am I audible?
Yes, sir, sure.
Okay. So how does the refractory periods? What does the refractory periods ensures in terms of action potential? I think this we have already discussed. It is just rephrased. So it is continuous depolarization, prevents backward transmission, enhances enhances sensitivity to stimuli, or accelerates repolarization. Yes, anyone would like to answer? Hello. Yes, Niranjana, you are trying to say something.
Sir, I think it enhances the sensitivity to stimuli.
Okay. Yes. Anyone else would like to answer or change the answer?
I guess it also prevents the backward transmission as well.
Okay. Any other answers? Yeah. Hello. Yes, Vikas sir. Good evening, sir. Hello. I think he's left. Okay. Yeah. Any other answers, or any would like to explain it? Paritosh, right? So how you think it prevents backward transmission?
I mean, the same logic which you use, that we are giving different, let's say, task to the computer at once. So it is going to
Yeah.
perform the first task, and then it is going to wait, and then going to perform the other one. So if it has already completed the very first task, there's no point of coming back and redoing it.
Mhm.
So
Okay,
that's how
and
it is.
yeah, Niranjana, why you think it enhances sensitivity to stimuli?
Uh, I'm not really sure, but I just remember like neurons, they require a little bit of resting time before they enter into any activity so that they don't get like overfired or something. So they do require some amount of time to get back to the normal state, and then they are ready to I mean, ready to transmit potentials again.
Yeah. Okay. So it prevents the backward transmission of action potential. Okay, ensuring that the signal moves in only one direction along the axon. So you can say that, let's say that we have some movement like this, okay, and this gate was opened for some time, okay. So some movement occurred, like some action potential occurred or some flow occurred, right? And this movement is going forward, like this will move towards throughout the cell and then go to the next wherever it is needed, okay, this potential. But at the same time, if this gate is opened again, what might happen? Yes, anyone? I think yeah, Paritosh, what will happen? Yeah, yeah, hello sir. Yeah, hello Vikas sir. Hello.
Yeah, I'm actually traveling. So can we do this
Yes.
sometime later?
Sir,
So,
this is a tutorial. Like I can continue with it. Not an issue, sir.
yeah, okay, fine. If there are any specific queries for me, please let me know. I think you can share my email ID and
Yes, sir.
I can connect up from there.
Okay, sir. I will do that. Thank you.
Okay, yeah. Thank
Yeah.
you.
Thank you, sir. Okay. Yeah. Yes. So, Paritosh, can you explain what will happen? Or yeah, Sajidi, you were saying something.
Actually, I couldn't understand what you are saying. This backward thing, not clear.
Yeah. Like you see, if this is the gate, okay, uh, gate or channel, you can say. If this channel opened for a time and it allowed the transmission of the action potential, right? So, what if this process is still going on? Okay, the transmission has not fully occurred, and or like this transmission had occurred, but it is still this action potential is still in the process in the neuron. Okay, and we are opening this gate again. So, what will happen? There can be since still this gradient and this gradient will have changed, right? Between these two neurons there might have been some change in the gradient. So in this case this potential can move backward. Suppose that the gradient has now become the opposite, so that can move backward also. So signal, instead of moving forward, will mix up and go backward. So that we want to avoid. Not we want, that is avoided using a refractory period. So this, there is some waiting time, you can say, that prevents the, like that lets the completion of the first communication that occurred to go forward, then the next one will occur. Till then this channel or this gate cannot open. That is the refractory period. Okay, fine. Any doubts in this? Hello. Okay.
We can go forward, sir.
Yeah, sure. Yeah. What is the function of potassium channel during the repolarization phase? It allows potassium influx. It enhances depolarization, allows potassium efflux, or activates sodium channel.
Potassium
This is the
efflux.
Potassium efflux.
potassium
Hmm.
efflux. Efflux means coming in or going out.
Out.
Out. So efflux is it allows the potassium to go out. This is the function of the potassium channel during repolarization phase. Okay. It opens during repolarization, allowing the potassium ions to move out of the cell. This is also selective, just like the sodium channel. Okay. Help to restore the negative charge inside the cell. Okay. So the action potential amplitude remains the same, but can vary in terms of, like we discussed that the amplitude of the signal, sorry, this this amplitude will remain the same, right? So uh, but it can vary in terms of frequency, duration, voltage, or repolarization speed.
Frequency.
Yes,
Frequency.
sir. Frequency.
Frequency. So different frequency means different stimuli, different level of stimuli. So it is not the amplitude. Like in normal terms, when the amplitude is higher, we say that the like strength is higher. But in case of this action potential, amplitude remains the same, but the frequency varies. Okay, the frequency is influenced by the rate at which stimuli is applied. Okay, yes. Any doubt till here? So, what is the primary? Yes, someone is saying something.
No, no, no doubt. No doubt.
Okay.
You can continue, sir.
What is the primary role of the action potential in neural communication? Synaptic transmission, muscle contraction, cellular aspiration, cell division.
Synaptic transmission.
Synaptic transmission, right? So, this is the primary role of action potential in neural communication. So, what is the direction of action potential propagation? Is it bidirectional? That means it can move forward and backward. It is unidirectional. It can go in one direction only. Circular, like it goes, like it comes in circular, or is it random? What is the direction of the action potential?
Unidirection.
Unidirectional. Like we have seen, sodium goes in but never comes out. And then potassium goes out, does not come in. Okay. So this action potential propagation is going in one direction.
This is the same thing for backward transmission, no? Like the case which we
Yes,
discussed.
yes. In case of backward transmission, then it will have a different. But since it is going, like since this is the action potential, like action potential is propagating in one direction. It never, and as well as we were saying that the gate will not open so that there is no backward movement is there.
Yes.
Yeah. Gate or channel. Yeah, I am using these terms interchangeably. Okay. Refractory period. Now we have discussed 2, 3 questions on refractory period. So I think everyone should answer this, right? Is a time when sodium channels are open, potassium channels are closed, channels cannot be immediately restimulated, or calcium influx occurs.
See.
See, channel cannot be immediately restimulated. Any other answers? Please speak up. Don't be shy. It's fine.
See, sir.
See, right? So that is the time ion channels are in a state where they cannot be immediately restimulated. Okay, this allows for recovery before the next action potential. So that is, you can say, if we are saying like this, we are considering as action potential. So it is the time between uh, time from here, starting from here till here. This is the refractory period, you can say. The start of action potential till start of the next action potential. So there is a gap or a time difference, that is the refractory period. Okay. What remains constant for a given neuron regarding action potential amplitude, duration, voltage, frequency, repolarization speed? Yes, anyone? It is regarding action potential amplitude. So
Sir, is it that voltage?
Voltage.
voltage. Yeah, voltage and amplitude are, we can say, the same thing, right? So the voltage remains the same or the amplitude remains the same of an action remains constant across different segments of neuron's membrane. Okay. Which part of neuron is responsible for receiving incoming signal from other neurons? Axon, synapse, dendrite, or cell body?
Dendrites.
Dendrites.
Dendrites. So this is the part which is responsible for receiving incoming from other neurons. Okay. So they are branched, like we draw earlier also. So if this is the nucleus, this the I am just drawing thin one. Okay. So this one was axon, and these are dendrites. So they will receive the input from other neurons, and then they are integrated into the cell body. And if they have to go further, what will be the path? This is where they will receive signal from different other neurons, and once received, that will go into cell body. Then if it has to go further to another neuron, what will be the path? Will it go through another dendrite? Axons. It will go through the axon, right? So this is a path, like it will go some, the path will be something like this. The flow of the signal will be from dendrite through the cell body towards axon, right? So dendrites are responsible for receiving the incoming signal. What ensures the unidirectional transmission of the action potential across the axons? Is it synaptic vesicles, refractory period, potassium channel, voltage gated channels? Voltage gated channels. This ensures unidirectional transmission of, oh, sorry. This ensures the unidirectional transmission of action potential. Is it right?
Both the answers can be there, no, sir?
We are saying
Well,
about
if
unidirectional. If this voltage gated channel can can it be opened? I think, yeah, Niranjan, not Niranjan. Yeah, Anu Krishnan. Yeah, you were talking about something where you are giving external stimulus using
Yes, sir. Yes, sir.
some voltage, right? So
Yes, sir. Yes, sir.
if we are giving a voltage, say minus 30 millivolt, okay,
Okay. Yes, sir.
and we have give once.
Okay.
and
Yes, sir.
that opened the voltage gated channel, right?
Yes, yes.
And during the refractory period, if you want to open it again, will it open?
No, sir. Actually, it is not going to stimulate. It's not going to open
Yeah,
like this.
it will
There is
it will not stimulate. Okay,
yes,
so this is something we cannot which
open it again.
cannot be used, okay,
Usable.
during this refractory period, and that is how this only one direction movement is ensured. So these
Yes, sir.
all and potassium channel all are controlled during the refractory period. So this is the time, this is the thing that ensures that there will be only one directional flow. Okay, whenever we are saying unidirectional, that means moving forward, not going backward. And whenever we are saying that there will be no backward propagation, then that is ensured using re refractory period. Fine. Any questions? Okay. The action potential waveform is primarily determined by the properties of the synaptic cleft, mitochondria, axon membrane, or Golgi apparatus.
Maximum membrane.
Axon membrane, right? Any other answers? Is it not synaptic cleft? Anyone? Yes. Any other answers? Okay. So it is influenced by the properties of the axon membranes, including the distribution of the ion channel. Now, next, what is the primary ion responsible for depolarization during an action potential? Yes, please answer.
Sodium.
I think this is, we have discussed a lot, right?
Sodium.
Sodium.
Sodium. Okay. So depolarization, sodium is responsible for the depolarization is what happens in case of depolarization? The sodium ions move outward or inward?
Inward.
Inward to into the cell. So this depolarization, where it must be occurring,
Inside the cell.
or
In the
will
axon.
it be in the axon or dendrite? Yes. Any answers?
Axon.
Yeah. What you are saying?
It must
Hello.
happen in the axon.
Axon. Okay. Any other answers?
If it is going in the inward thing is the dendrite, so it should be dendrite.
Yes. Because that is the point where we are receiving the signal, right? So if something is moving in, that must be dendrite. Okay. What what does the refractory period contribute to the overall function of the neuron?
Sir,
Prevent
previous
signal
question I
amplification.
couldn't get, sir. Can you explain little bit more? Previous question.
Yeah, we are just asking what is the primary ion responsible for depolarization. So in case of depolarization, we have seen that it is the sodium ion that is moving in the cell, right? Like moving through the channel in. So sodium ion is the one that plays role in case of
Sir,
depolarization.
that is polarization only, no? Sodium and entry is polarization. Potassium going
Yeah,
out is depolarization.
no, that is repolarization. There is this depolarization
Okay.
and
Okay.
repolarization. Yeah. What does the refractory period contribute to the overall function of the neuron? It prevents signal amplification, enhances synaptic transmission, accelerates repolarization, or allows immediate resimulation.
Enhances synaptic transmission.
Okay. Yes. Any other answers? Yes. Anyone with any other answers or any explanation for this?
Diffractive period basically means a one-way flow of the uh, yeah, one-way flow. So basically, whenever we are talking about the synaptic transmission, so if it is one way only, so refractive period is basically kind of enhancing it, I guess.
Okay. So it prevents the excess signal amplification. Okay. That no overloading of signal occurs and ensure that action potential are discrete, like they are separated from, like one action potential is separate from another action potential, allowing for accurate signaling. So it prevents signal amplification over, or you can say overloading of the signal. Fine. What is the primary function of the axon in neural communication? Is it signal reception, signal integration, signal transmission, or signal termination? So is it receiving, or is it doing some processing, or is it
Trans
yeah,
Transmission.
transmission? Uh, yes, Niranjana, you are also saying something.
The same answer, sir. Signal transmission.
Transmission. And Aditya, yeah, your answer. Is it Aditya or Aditya? Hello.
Aditya.
Yeah. So, what is your answer?
Transmission.
Transmission. Okay. So, for transmitting action potential, which carries signal away from the cell body, but it is not terminating. Terminating means it ends the signal there. Okay. It is termination will mean that it will end the signal there. It is just transmitting. It is not doing any processing over it. It is just transmitting towards other effector cells. Okay. Okay. I think this we have already discussed, no? In terms of wave dynamics, what do action potential creates
Yes.
across cell membrane? Yeah. Yeah. What is the answer?
Traveling waves.
Traveling waves. Okay. What happens during a refractory period regarding channel activity? So the channel remains open during refractory periods. It becomes more sensitive. It cannot be immediately resimulated, or it allows bidirectional transmission.
See,
C. Cannot be immediately resimulated. The channel remains closed during this time. Channel become less sensitive and they cannot be immediately resimulated, and it allows unidirectional transmission. Fine. So these are actually, you can say that this the uh, summary of what happens in case of a reflect in during the refractory period. Fine. Any questions? Okay. What aspects of action potential varies with the frequency of stimuli? duration, voltage, amplitude, repolarization speed. This also I think it is repeated. Yeah. So what is the answer?
Repolarization speed.
Is it a repeated question?
No, no, right, sir.
No, sir. That was regarding amplitude, this regarding
Amplitude,
frequency.
yeah.
Yes. Yeah. This is regarding
Okay, so
frequency.
answer is D, sir. Is it answer D?
We are not going to play this A, B, C, D, right? So you will have to come with some reasons. Why is it so?
Sir, this
Sir,
since the repolarization speed means
No,
the
here the
refractory period
yeah.
time is less, so the
Okay.
frequency will increase if you are stimulating. If the refractory period is less, means we can stimulate it again and again in less period of time. So the number
Yes.
of action potential generation also will increase. So the
Okay.
frequency varies according to that. That's why
Yeah.
it's repolarization.
Yeah. Niranjana, you were also saying something.
I thought the same too, sir. Repolarization, sir.
Depolarization speed. Okay. The frequency can influence the duration of action potential, right? Higher frequency means lower duration, while lower frequency means longer duration, right? So it is the duration of action potential that varies with frequency.
Okay, sir. Okay, sir.
Okay. So like the amplitude is remaining same, but it is the duration that will change with the frequency. Fine. So any questions? I think it was too fast, or was it fine for you people?
Sir, can you elaborate the last question's answer? Like,
Uh, See, where is with the action potential? Like when there will be different stimuli, the amplitude remains same, right? But what amplitude remains same means voltage remains same, the action potential, the potential remains same. But what varies in different action potentials? Yes, anyone? What varies in case of different action potential?
Sir, frequency
Sir,
will vary, so it reach the signal very fast one end to another end. That if you see that one, that is a speed only, duration. So we can
Yes,
think like that, frequency domain to time domain.
time domain. Actually, frequency and this time are related only. It is this duration is inverse of frequency. So, duration like there can frequency means number of occurrences, number of occurrences in unit time or fixed time, you can say. Okay. So, yes, Paritosh, you are saying
So
something.
by this, do you mean that one of the action potential is occurring, let's say, for a time duration t, the next potential action potential is occurring for a duration of 2t? Is that what you are meaning?
No, I am not saying T2T. Yes, there will be like T1, T2, T3 based on the stimulus. If the stimulus is different, there will be different time period, time duration for the action potential. Whereas if it is the same, it will be having the same time period since the frequency will be the same.
And what does this repolarization speed implies then?
That is like you can say one polarization to another polarization. Not polarization, sorry, repolarization. Repolarization
So
is when what happens in case of repolarization?
the potassium will go out.
Is it repolarization or depolarization?
Yeah, in case of repolarization, potassium will
Repol
go out.
God, right? So uh, you can say this is some term just I have put, like there is no specific term like this. Okay. So I have just put it for thinking that the time bet the time between one repolarization to another repolarization.
Okay, sir. Okay. So it means like uh, it is going to occur
This
very
this
fast.
yeah, this is not a standard term. Okay. I have
Okay,
just
okay.
put it in as a choice so that you can think about it. Okay.
Sure, sir. Thank you.
Yeah. Yes. Any other question?
Sir, could you also give an introduction about yourself?
Okay. I think you missed
Yes, sir.
the first part. I think. Let me directly go. Okay. We have already drawn a lot on this. Just I will share sir's email ID on the next like in the next week. Okay, I have not put it down here. So my name is Vikas Pandey. I am a PhD scholar at IIT Jodhpur in space science and technology. I have a bachelor's in electronics and communication engineering and a master's in VLSI. I have worked as robotics trainer, online faculty, as well as R&D engineer before joining a PhD. For more details, you can visit my page and the YouTube channel where all these recorded classes will be put. And if you have some query, you can ask in the class for sure, but or you can mail me on my email ID. Yeah. Any
So
other
you'll be
questions?
sharing this PDF as well, right?
Yes, I will be putting this PDF on the like in the course in the on the bottom you will see there will a link will appear which will have live interactive sessions there. If you click a Excel sheet will open, Google sheet will open. On that all this link for the slide videos everything will be put there.
Sure, sir. Thank you.
Okay. Yes, any other questions? Yes. So if no question, I think we can close the session for today. So we will be meeting in the next class at the same time. So thank you all.
Thank you.
Every